But hello boys and girls, here we are, made it to the fourth one. Today we're going to talk about some stuff that I have no conclusions on, and almost no one else does either. But that's the kind of stuff that I actually think about, and maybe you can think about it too and see if maybe you have one of those epiphanies that you've heard about. Maybe all of a sudden a light bulb will go on and you'll write a scientific paper and get a $200,000 a year grant, and you will be a theoretical physicist working for Caltech, write a book, become famous. Or you'll just smile and go, oh, so that's what that's all about. Today we're going to start off by talking about nothing. And you might think there's two categories. There's nothing and there's something. I really think there's only one category, and that's there's something. And there's no such thing as nothing. But let me explain. First, what's the definition of nothing? Well, it just, when you look it up, it just says not anything. Something that does not exist, or the absence of all magnitude and quantity. All right. But is there really such a thing? Most people don't think about it, but there are literally teams of scientists that are exploring nothingness, and I'll explain why. I guess it was in the 1800s sometimes. They believed that they had discovered nothingness by creating a vacuum, sucking all the air out of a jar and go, okay, here it is. This jar is filled with nothing. There's nothing in it. But they didn't know about electromagnetism or gravity waves. So they just didn't think much more about it. But now they're trying to figure out how to make a vacuum of electromagnetism. How can we get all the electromagnetism out of something and see what happens? Or how can we get all the gravity waves out of something and see what happens? And so far they just don't even know how to get started with that. But what you might think about is there something that exists that doesn't have matter, weight, any size, anything that you can't see, feel, touch, taste? Does anything like that exist? And you might think, what about a thought? Well, that's electrical impulses, is it? Is it just electrical impulses that's in your brain? What about my little, let's see, what have I got here? Alright, let's use this. I was going to pull up an SD card, but this will do the same thing. This is I think this is a terabyte. Okay, this is a terabyte hard drive. It weighs, let's say it weighs exactly 18 ounces. I have a terabyte of stills and videos. I mean, literally tens of thousands of still photographs and probably 50 GoPro videos, drone videos. It still weighs the exact same amount. What did I say? 17 ounces? Okay, it would start out at 17 ounces. Now it's completely full of stuff and it still weighs exactly 17 ounces. But it's not empty, it's just full of stuff. I can't get it off there until I plug it into my computer. But do you get the idea? That is something that exists that doesn't have weight, it doesn't have volume, doesn't have any of this stuff. All it is it boils down to, if you understand what the binary hexadecimal system is, we call it a series of zeros and ones, but what it is, it's a little magnetic door, I guess the best way to explain it, it's either open or it's closed. And there's 8 of them in a byte. And that tells the, how can I explain it? That would tell the electrons whether to go this way or to, this door's closed, you have to go to the next door. Anyways, when it's all done, maybe all that means is the letter A on the screen, or maybe one pixel that's a certain color, right? So there are things that exist that are beyond our time-space continuum ideas. Or I wouldn't say they're against the laws of nature, but they're beyond it. They're not against it, they're beyond it. So the scientists, I've read several scientists now, and together they are thinking the universe sits on a platform of shoddy construction of metastable, they call it. Remember that word, metastable? Doesn't mean anything, I guess, because they said that the vacuum is doomed to nothingness. So that's what they come up with. That doesn't sound like very good science to me, but that is what a lot of these guys have come up with. So if you go to the quantum world, they found that, now this is all going to go back to nothingness, alright, it's going to circle around. You will find that you can never catch a quantum field with zero energy. In our universe we have what's called a scalar field, sometimes it's called the Higgs field. It exists everywhere at the same time. It permeates the universe. It's changed its state over the eons of time, but it has never been zero. And it's this property that gives our particles mass. How can I explain this? If you were as old as I am when the computers first came out and Windows first came out, you had a cursor and I remember the first time I used a mouse, I thought that was crazy. I could move this thing around and the cursor moves around. But back then, there were no edges. In other words, if you moved the cursor off the screen, it showed up back on this side. It never stopped at this edge. It just went off and then came back on. If you went up, it would show up at the bottom. If you've ever watched the movie Thor Ragnarok, where he's in that, I guess like a prison with the rock guy, and he takes off running, and he off the screen this way, and he comes back on the screen this way, and he goes, "What's going on?" And the rock guy says, "Oh, it's a circle. It's kind of a freaky circle." Well, that's kind of how our universe is. There is no edge where you could stand on the edge and look out and say there's nothingness. That's my idea anyway. We don't have an edge. We're built in such a way that it's beyond describing, but I think that's what it is, and I'll elaborate more on that a little bit later. But I do believe the bubble theory. We had the string theory, and that's kind of been, a lot of scientists are finding flaws with that, and they come up with, okay, we're a bubble. We're a bubble inside of a bubble. Well, that's kind of what the Bible has been teaching for thousands of years. The Bible teaches that there's the big bubble is heaven, and the little bubble is the earth and its universe. See, when you look at the Greek words for the heavens, we just translated English as heaven, but there's three words. I think it's Oranios, I forget the other two, but one refers to our atmosphere, clear up to the troposphere, and then the next heaven is the outer space, I would call the rest of the cosmos. And then the third heaven is beyond all of that. It's the abode of God. So the heaven I'm talking about is the abode of God, and then He created the heavens and the earth inside of His heavenly realm. Think of it like this. God decides He's going to create a cosmos, and he has this idea, the way He's going to create it, and He's got a plan for it. He goes to the cupboard, and He gets out, how many elements do we have? 109 or whatever it is. Maybe we have some elements we haven't discovered yet. So He grabs a handful of elements, mixes them in a bowl, throws in some laws of physics, then He compresses that down to the size of a mustard seed, and He tells all the heavenly host, all right, you guys, get back. Everybody get back. You, Gabriel, get back. This is going to get really big really fast. And then He speaks energy into it, the Big Bang. Right? And all that is happening inside of God's heaven. And so when the scientists start measuring things and pulling things apart, and CERN, colliding particles, and they say there's something else going on here that's just plain beyond our physics. We don't know what to do with it. That's God's heaven that has a whole, I wouldn't say different kind of physics, but has all the physics of our cosmos plus some stuff that we don't even know about. We can't even conceive. And that's interacting with our cosmos because we're inside of it. So I kind of got off on a tangent there, and that happens. So I guess nothingness, in my mind, doesn't exist because everywhere, all the time, in our cosmos and the heavenly cosmos, is something. And at the very least, it's some sort of an energy field. Some Eastern religions would teach it's God. God is that force. But they make it an impersonal force, like a Jedi using that impersonal force. But in the Christian mindset, yeah, you might call it God, but God also has a individual personality, and that makes him a person. And while you let that rattle around in your head, let's talk about time, and it will relate to that. In dictionary.com it says, time is the system of those sequential relations that any event has to any other as past, present, or future. Indefinite and continuous duration regarded as that in which events succeed one another. That's just another way of saying the interval between two events. All right. In the Cambridge Dictionary, you think, oh, Cambridge, these guys have probably got a little more tweak to it. Let's see if they do. And they say, this is their definition of time: the part of existence that is measured in minutes, days, years, etc., or the process as a whole. That's a pretty sucky definition if you ask me. There are teams of scientists that are investigating time, not so much what it is, what it does, but what it is. What is time? How does it work? You go back to Newton, and he thought time was a constant of the universe, that it's the same everywhere. A second on the Earth is the same as a second on the farthest distant galaxy. But Einstein postulated that the only constant was the speed of light, and that time varies like a river ebbing and flowing, affected by gravity and motion. His theory was proved in 1971. They took 4 clocks, cesium clocks, and they flew them around the world. The clocks going, they flew them east and then they flew them west. All right. The clocks that went eastward were 59 seconds slower than the clocks that were Earth-based. The clocks that went westward were 273, I shouldn't say seconds, I should say nanoseconds. All right? The clocks that went westward were 273 nanoseconds faster. Therefore proving that motion, velocity, momentum, what do you want to call it, affects time. So knowing that, that's when they come up with the idea that time is a 4th dimension. Okay, so we got that part. Time is not constant, but it flows in only one direction, that's forward. So in Einstein's general theory of relativity, you have space and time expands and contracts depending on momentum and mass of nearby matter. Have you seen the movie Interstellar? That's a pretty good movie dealing with time. And it kind of bends the mind, but I think it's probably pretty accurate. So there's one of the scientists come up with a little one-liner. You can remember the past, but you can't remember the future. Well, isn't it interesting that I gotta let Joe out now. He wants to go out. Come on, Joe. All right, where was I? Okay, a star explodes a million light years ago. And today we just saw it on our super telescope. We saw this supernova explode. So something that happened a million years ago, just now affects us. We just now saw it. So isn't that, I mean, what do you think about that? So the past, things that happen in a different time, I don't want to call it a continuum because we're all in a continuum, but something that happened in the past affects our present. It's the same thing with choices. Your choices in the past affect your future. Okay, my camera died again. I have to figure out what that is. It's not battery. I think it overheats or something. Anyway, besides Joe wanting in and out, because I'm his slave, I have to do whatever he wants. And my camera dying because I'm my own cameraman. I don't have a flip screen where I can see if it's recording or not. There's no red. Let me make sure. Yes, I had to make sure. It said recording on the back. There's no little red light here that tells me. It's easy for me to lose my train of thought. There's something else you can know about me. I was talking about past and choices. Kind of a grandpa to grandkids thing. The choices that you make right now are going to affect your future. My choices of the past have affected my present. Choices, choices, choices. But because I've lost my train, I'm going to go back to my notes, and I might repeat myself. Old guys do that, and I'm an old guy. So let's talk about how time works. Professor Sean Carroll, a theoretical physicist at Caltech, that's what he does for a living. He makes a lot of money working for Caltech, trying to figure out how time works. Not what the space-time part of it, but he specializes in the arrow of time, you know, the direction of time. And there is kind of a reason for that, because they're trying to get down to the nature of reality. When you have to know everything about everything. Is there such thing as nothing? How does time do its thing? Now, they've got pretty good at it, and they have teams of people, not just him by himself. But here's something that he says, and I'll quote. He says, you can turn an egg into an omelet, but you can't turn an omelet into an egg. Right? Time only goes one way. There's a guy named of Ludwig Boltzmann back in the 1870s. He figured out entropy. Entropy says there is a measure of how disorderly things tend to grow. In other words, everything becomes more and more disorderly. How can I explain that? The second law of thermodynamics states that all things tend toward total entropy. In other words, everything goes from an orderly state to a disorderly state. It actually, more properly, to symmetry. Symmetry is not what most people think it is. Symmetry is, how else can I say it? Symmetry is balance. One scientist said all things tend from a grouping order towards symmetry. What's the ultimate group? Would be one thing. The universe started as a singularity, which is just one thing. Symmetry would be like if I set off a red smoke bomb, and it's in this room, and you see it swirling and swirling, and there's some red swirls and some pink swirls, but if you leave it alone, it wants to balance out, and eventually every square inch of this room will be a certain shade of pink. Everything's the same. It all balanced out. That's symmetry. If you put a hot coal in a metal box, and on the other side you put a ice cube, eventually the coal will cool off, the ice cube will heat up, melt probably, and eventually everything in that box will be the same temperature. The burned out coal will be the same temperature as the water left over from the ice cube. That's symmetry. Everything wants to balance. Positive and negative. Alright? And it all follows that arrow of time. It goes from one order of grouping to symmetry. You could even, they're pretty sure, as sure as scientists can be, because they change their theories of everything every couple of decades, from the string theory to the bubble theory, but I'll talk about that a little bit later. But everything goes from a singularity state, that exploded, it all expanded, and at the other end of it is, they call it heat death or absolute zero, which I think is 460 degrees below zero, when nothing is happening. There's no motion, there's no electrons swirling around, neutrons, there's no nothing happening. That is the other end of it. That's complete symmetry. Now back to Dr. Carroll. He says, quote, if you find an egg in your refrigerator, you're not surprised. You don't say, wow, that is a low entropy configuration, that's unusual. Because you know the egg is not alone in the universe. It came from a chicken, which is part of a farm, which is part of the biosphere. With the universe, we can't say it's part of something else. But that is really exactly what I'm saying. The Big Bang was not the beginning. See what they're concluding here? That there's more than this universe. There's more than this cosmos. And he also says, quote, "The weird thing about the arrow of time is that it's not to be found in the underlying laws of physics. It's not there. It is a feature of the universe we see, but not a feature of the laws of the individual particles. The arrow of time is built on top of whatever local laws of physics apply." That that is like he more or less come to the point when it is just saying there's more to this. We'll never get to the end of it. That's my wild theory. That's the way God built this stuff. But in their mind, they won't say the G word. They won't say God. They will just say there must be something else, and we think it's that there are infinite number of universes, and that our universe bubble is connected to another universe bubble, and we're getting effects from that other universe that has physics. They just won't go to, wait a minute, the Bible's been teaching that for a long time. We're a bubble inside of a much larger bubble. Here we come back to time. So if time is an interval between two events, now this is just according to our cosmology, at the point of singularity there's only one thing that exists, and that's that singularity. So there's no events happening, there's no two events, there's only one. So that's timelessness. Time has not started. God breathed into it, it exploded, and events started happening, and intervals between those events started happening, so time is happening. At the other end of the spectrum is this complete symmetry, and at that point there's no events happening, there's nothing happening. Everything is cold, everything is stopped moving, there are no events happening, so you have timelessness. So between timelessness and timelessness, we have time. And God has built it that way so that when you investigate it, you should say to yourself, wow, there must be something beyond all of this that's causing all of this, that leads you to the personality of God. So I hope I haven't bored you too much. The next episode, I believe, is going to be more interesting. It comes from the book called The Science of God by Dr. Gerald Schroeder. And we're going to get into time again, but we're going to bring it in out of the abstract into the reality. And I'm also going to throw some more stuff at you by Gervin Gillibrand's book called Everything Forever, Learning to See Timelessness. We'll marry those two things together and give you that to rattle around inside your head. So with that, I love you guys and stay tuned. Bye.